This is the third video in our AWS Developer series. In this video, we're going to go through how you can set up and run a basic Kinesis test. To start with some quick background. Firstly, the AWS Kinesis Java SDK is really best for building a framework where you can construct producers and consumers. AWS provides just such frameworks. KCL or Kinesis Consumer Library allows you to create consumers. KPL or Kinesis Producers Library ditto for producers. Having said that, sometimes you need to fall back to the code that exists in the core Kinesis Java SDK. For clarity, we have a consumer library, we have a producer library, and we have this core SDK. We'll call that a client. It's neither a producer nor a consumer. It's just something we can call to access the raw Kinesis framework when we want to do something like create a stream. Generally, when we build a Kinesis consumer, it will filter the Kinesis stream that it's wired into, and that will be based on some condition in the data. In this test, we have a filter which selects a particular type of target record and pushes it to S3. This is a high-level architecture diagram of the test architecture, so we can identify and understand the role of the artifacts involved. We have two containers, a Localstack container, which is running Kinesis and S3, and a DynamoDB table, which our Kinesis client must connect to set up what it calls lease tables. The Kinesis Producer library, which we use to create our producer, mandates HTTPS. This means we need some additional environment variables in our Localstack environment to allow TLS or Secure Transport Layer. The connection for the Kinesis client to DynamoDB does not require HTTPS, so it can just run on HTTP. This is the Docker Compose file we will use to build and run our containers. We have two containers, a Localstack container and a DynamoDB container. We have some port mappings. We're not using the Docker Bridge network for this test. In this test, we have a few critical environment variables, and we'll just focus on the role of these environment variables now. If we refer to our Localstack container, we can look at the environment section. The first variable we see is this AWS _ CBOR _ disable equals 1. This variable is an actual AWS SDK variable. The rest of the variables in this section refer strictly to Localstack. The Localstack needs the CBOR disable variable because it's using the AWS SDK itself. We will need to, at a minimum, set the AWS CBOR disable variable everywhere in our code, in the consumers and the producers, where we use the AWS SDK, which for us is everywhere. The use SSL equals true variable flags Localstack to set up its mock endpoints with HTTPS. As a result of our local use of SSL, we're going to have to set up variables in our code so we turn off cert checking and allow self-signed certificates. Finally, our DynamoDB container is running on port 8000 and it's just a vanilla Docker pull and run container. Just some brief details about what's going on behind the scenes with these environment variables and what Localstack is using under the hood. So Localstack is using Kinselite. Kinselite doesn't use CBOR, which is the default protocol for the AWS Kinesis SDK, which underpins everything. So that's why we have to disable CBOR for the AWS SDK code and only allow JSON, which is all that Kinselite will work with. There are many AWS SDK environment variables, and we can find out all the information about them in this one AWS SDK class called SDK Global Configuration. You'll find that in the online Java docs for the Java AWS SDK. This is just a screenshot of a Java doc for the SDK Global Configuration class, where you can see the properties. So we have a CBOR environment variable, but we can also set it up as a system property. So to find out the available options for the environment and the system for configuring the AWS SDK, reading the Java docs for this class is a good starting point. Thankfully, we can find in that SDK Global Configuration class another system property that we can set to allow self-signed certificates. It's a system property called Disable Cert Checking System Property. And if we set that to be true, it will allow us to work with self-signed certificates for calling Localstack with the AWS SDK in both the producer and the consumer. We will also need to not forget to set the CBOR Disable environment variable to be true when we call Localstack running Kinselite behind the scenes with the AWS SDK. We're about to briefly discuss the code we use for the tests now. The code is the simplest code we can write. These videos are focused on how we set up and run AWS tests for things like Lambda functions locally. So we're not so much concerned with how we write code for AWS services, but how we can set up tools to test such code. The code is a multi-module Gradle project. The Commons module just has constants and configs, so if anything is common to both the consumers and producers module, then it's refactored into the Commons module. The containers directory is where we keep the container code as before. We only have a single Docker Compose file for this test. Code builds with the Gradle wrapper with clean, build, and excluding tests, but I build with the latest version of Gradle. I'm using the latest versions of all the dependencies, so if you have any problems getting the code to build, try and use a recent version of Gradle greater than or equal to Gradle 5. Once you've built the project, you'll be able to find the build artifacts in the following location. For the consumer, go to the consumers module in the build directory. In the libs directory under build, we can find consumers-1.jar. And we can just run this jar with the java jar command. I built the code to run in Java 11. Similarly, for the producer, in libs under build, we find producers-1.jar and we run it with the jar command. Again, everything is set up to run in Java 11. Just some final notes before we run the code. So firstly, both the consumer or the producer will create Kinesis stream if it doesn't exist. This means we can run them independently. We can run the consumer before we run the producer. Similarly for the producer. Secondly, both the consumer and the producer and Localstack all require the environment variables that we went over in detail. The producer is asynchronous. It's just going to push all the data it has into the stream and terminate. Whereas the client is more synchronous in the sense it's just going to wait patiently to find data in the stream. When new data turns up, it's going to process the data and then sleep and wait for more data to arrive in the stream. Now we'll boot up the containers and run the test. Once we've checked the code out from GitHub, we can build the code with the Gradle wrapper. And here you can see it's building the consumer's jar, and then it's going to build the producer's jar, and we're good once it completes. Build fat jars. All the dependencies are packaged in the jars. Just to check, we go, as we previously pointed out, to the locations, check that we can find the actual fat jars that we have produced with our build. Now that we've built the jars, it's time to boot up the containers, the Localstack container, DynamoDB container, running off our Docker Compose file where we've defined everything and set up the environment variables correctly as we previously discussed. We build and run our containers with Docker Compose up. We should see a Localstack container boot up and a DynamoDB container boot up. So everything is starting up. We wait for Localstack to be ready and expose the services S3 and Kinesis. So Localstack is ready. It's time to run the jars. So we go into the respective directories. So we're going to run the producer first, the libs directory. We're going to run the jar. We issue the Java command to run the jar. So in a terminal, issue the command java-jar and the name of the jar, which is producer-.jar. When we run the jar The producer is just going to push all its data into the stream. It's going to wait for a callback in the code to check that the data made it into the stream, and then it's going to terminate. So we wait now for the callback. There's the callback. So the callback tells us that the data was pushed into the stream successfully. Once the callbacks have completed, the producer terminates. Now we will follow the same procedure to run the consumer. The producer has pushed its data into the stream. The data is in the stream. The data stays in the stream for a default period unless you set it. That default period is 24 hours. The data is persisted in the stream, and when we run the consumer with java-jar, consumer-1.jar, with that command, when we run the consumer, we're going to be able to look at the data that we've pushed into the stream. Now, Kinesis is very configurable, so you can play back from various points. So we're just going with the defaults. So every time we run the consumer, it's just going to play whatever data is in the stream from the start. Now, don't worry about these exceptions. It's just calling the Localstack service because it wants to talk to DynamoDB and make a connection to set up the lease tables. So it calls again. So now, because it's moved on, it's successfully set up the lease tables and polling the stream. It's processing the records. So you can see it's processed the record. And there's one record that had a particular text data set, and it filtered on that record, created a bucket in S3 and pushed the data to this bucket called test bucket. So our test ran successfully. Everything worked out. We're able to set up our producer and consumer. Now if we run the producer again, so let's run the producer again, firing off our producer, it's going to push the data to the stream. Everything worked quicker this time because the stream and everything was set up. Now if we look at our consumer, we can see it's processed the data a second time, created a second bucket, and pushed a second set of data to the S3 bucket. So everything worked out and we're good with our test.